Hi, Ashwardhan. Nice to meet you on Google Meet. Uh, what has been keeping you interested in the field of machine learning of late?
Hi, Akash. Nice meeting you again, and also thank you for this opportunity for sort of sharing my ideas, my research, and sort of the opportunity to discuss these topics with you. Off late, that's a good question. So I think off late, the season has been mostly about LLMs, and as a related note, I think what has sort of kept me hooked on, I should say, is multimodal LLMs in some sense. So basically, it's got to do with how do we interface different modality and use the LLMs for a much more extended understanding of our world,
Okay. So,
our
in the
context.
has let's say that you come from a historically speech recognition world. Has that world completely changed with the I wouldn't call it advent of language models or large language models, but at least the vast adoption of language models?
Uh, I definitely think so. It has. It has impacted a lot of fields. I mean, the breakthrough technology, in some sense, has been the 2017 paper of transformers. In some sense, so that has permeated a lot of fields, including speech recognition, image processing, computer vision, and all that stuff, right? Which were predominantly convolutional nets heavy at some point. And so I think that has so in a deep sense, the in terms of the architecture, that has been one major change over the last 5 to 6 years. The other thing is also about these LLMs, right? Like language models have been used in speech recognition for quite some time now. That's not a new thing, but I think using these large language models in order to sort of decode as well is something that's catching up.
And the paper you're referring to is "Attention is All You Need."
Attention is all you need.
And prior to that, what was the dominant let's say the theme in research, and how did this particular paper change sort of those previously known themes?
That's a good question. So I think that paper impacted different fields, so basically, if you take speech recognition, the dominant technology was recurrent neural networks based on LSTMs or GRUs for some groups. Um, so these have been for I think since Alex Graves' paper, maybe since 2009 or so, LSTM sort of caught on, and even before that, it was predominantly just HMM based, these hybrid systems where there was neural networks were just used for predicting the sort of the class density functions within the HMM for the phonemes and stuff. But after that, it was predominantly recurrent neural networks, which were shown to be super powerful for a long time. Then came the and in the so in the text world, NLP, and in speech recognition, it was predominantly RNN based LSTMs and GRUs. In the image and computer vision world, I would like to believe that it was predominantly convolutional based kind of networks. Of course, I'm not an expert in those areas in the sense that I was not part of the revolution back then, but it's based on what I can glean from the papers. And the introduction of transformers was sort of very neatly motivated in some sense. It was saying, so in order to train these LSTMs, right? You can think of these LSTMs or recurrent neural networks as a repeated application of the same feed forward net in time. So there is some concept of unrolling these networks, right? Like it's almost like the same feed forward network with the same weights frozen. You keep applying that to every time step. And then when you backpropagate, there is this notion of backpropagation through time, which was a beautiful concept introduced back in the 90s, wherein it's almost like it's the same feed forward network. And if, let's say, you want to, backpropagate for 30 time steps, you would unroll it and sort of do that. So as you can guess, naturally, there is a sequence that has to happen in training. And whenever there is a sequence, it limits parallelization. And therefore, the GPU compute that you can maximally utilize and the biggest networks that you can train were all sort of limited with RNN based networks. And what this transformer based networks did, it basically said, let's forget this recurrence completely, and basically do something else. Like, I want to make sure that at every time step, every other time step, information is available. One pretty cool way from signal processing that we know of to do this is match filtering, cross correlation, or autocorrelation, right? It's essentially that's the fundamental operation that's happening within a transformer block. If you see, if you look at the self attention and stuff like that. Um, so so what that did was basically help paralyze these operations even during training. So
Okay.
that and then the point was you could sort of rapidly. The only point was you need to build networks which were much more deeper, much more larger than the RNN LSTM based networks. But the plus side was these bigger networks were able to digest more data and perform significantly better. So that was shown in the NLP domain, right? So you would assume that, okay, this looks interesting for text and stuff like that. But soon there was a revolution in the image and the computer vision domain, wherein they said, okay, how do we use transformers? These transformers looks like a great utility. How do we use them? They came up with a very simple, nice trick, the good old raster scan from the CRT monitors and TVs that we know of, right?
Can
With
you
that
can
raster.
you expound on that, the raster scan?
Oh yeah, so essentially image is basically a 2D information, right? As opposed to in the text world, wherein each sentence basically is tokenized, or imagine that every word has basically a representation. So a sentence is basically a sequence of vectors, right? So a sentence can now neatly be represented as a matrix. If you convert every word to an embedding, it could be a simple embedding, which could just be a one hot vector in a huge vocabulary, or it could be a word vector, or it could be something else altogether. But essentially, one vector per word, and therefore a sequence of words is a sentence, and that's a matrix. Now, image by default is a 2D information. It's not a 1D flow of information. There's like something happening along the X, along the Y, and so on. So what they did was they needed a way to convert this 2D information into sort of like a 1D sequence. And the way they did was basically to say, let's break down this image into patches, and let's traverse this patch in a particular order. For every image, I'm going to do a raster scan, go from left to right, swing back left to right, swing back left to right, and so on. So this 2D information now is now captured as a sequence of patches, and each patch basically has an embedding. And now with a very simple operation, I have transformed the problem of image processing and computer vision into that of sequence of token processing, or sequence of embedding processing, which is similar to NLP. And now, well, I can still use the transformers. And that was the breakthrough for the VIT paper. It's a vision transformer paper. I can basically send the link later on, but essentially that happened. And audio guys were like, okay, we have been used to thinking about spectrograms as an image for quite some time now. Let's do the same thing. Same thing happened there, and audio spectrogram transformer paper from the MIT group was exactly that. And therefore, just see how transformers, sort of change the way people do things in different fields, right? So for NLP, it was quite obvious. For image processing and CV, this was the small raster scan helped them use transformers. Same thing with audio and speech.
And given that, if we talk about multimodal, which is essentially combining them in interesting ways for the use cases that you see in the real world, I think having, given the assumption that transformers are a huge step change in terms of the way people train and utilize these models, how do you see multimodal models as a
So
way forward, considering various use cases?
yeah, I mean, since the sort of the rebirth of deep learning, I would say, since the 2010 era and so on, and after the transformers, one thing that it has facilitated is an expert in speech need not be just limited to speech recognition or speech processing or audio processing. He can go on to image, vision, and everywhere. And it's like the moment you transform these signals into a particular place, the same expertise can now be applied in different fields, right? So there is this reusability or the transferability of these skills, so to speak. So, and another thing in terms of the multimodal processing, if you were to think about doing this multimodal processing back in the 90s or the early 2000s, I literally had to use different state of the art, like the state of the art systems were completely different. What looked for speech was was speech recognition was different. What was for image processing and computer vision were completely different. There were hand rule-based systems and so on. And if you want to combine all of these and then sort of extract information from that, it would be a nightmare in some sense. It would just be about glue code holding different systems together and then superficial alignment and so on. But if you do it today, everything is transformer based. So you can unify the processing of these signals at a much more deeper level, and the whole systems become much more simpler, much more easier to handle in some sense. There are other challenges though. I am glossing over. Okay, for to do multimodal, learning in some sense, do we truly have multimodal data that is labeled? If not, how do we do it, and so on? Those are some other challenges. But at the architecture level, right? And if you think about training these systems and deploying these systems, assuming the data is available, it makes it so much more elegant and so much more easier and so much more scalable.
And given that LLMs have attractive qualities to them, and I think you've covered a bunch of them, but are they qualities that you've left out which makes it attractive?
I think, in my mind, the biggest attractive quality about these LLMs, in some sense, was their ability to generalize to unseen things, unseen tasks, unseen prompts, and so on. And I think that was the biggest wow factor for people. People were sort of used to the fact that, okay, if you're trained on this task and if I test on it, it's performing well. Okay, yeah, it's explainable. You trained on it and it's working well. But I think the biggest wow factor for most people was that they didn't even, a lot of these tasks, a lot of these questions that people were prompting the LLM with, it was not trained for it, and yet it's able to do it. How is that? That's really the sort of the wow factor there. So basically, the technical term is generalization to unseen tasks, and so on.
Is it the reason that because language, which is underpinning all the activities that we do, is the common denominator here, and because language is ever present in all our activities, which underpins what we call intelligence eventually, is that the reason why it's generalizable?
I mean, let's answer this question in two different levels. One is at the sort of the ground technical level, and the other at a more philosophical level, or whatever, right? Like at the grassroots level, um, what really helped in generalizability in my mind is, in some sense, multitask or even unification of tasks. Let me take a couple of steps back. In my mind, the way the field has grown in some sense in every different fields of subfields of machine learning is, initially people were great in doing single task learning, right? Like there's a task, label this image, detect this object, draw a bounding box, or basically say, recognize this phoneme, blah blah blah, any task, right? That task, they had labeled data sets. Here's an X sample, here's a Y label, and so on. Let's do supervised learning, single task with that objective function, whichever minimizes that loss, you train. It works well on that task, and then you would have a held out set, test set, or whatever, measure the performance on that. Go on. And then slowly people started saying, if I train it on one task, it's not that it's great on the other task. It was not even trained for it, and you can't even sort of test it. So then how do we do multitask? So then people started building some frameworks for multitask learning, wherein basically there was an auxiliary task, there was a main task, and they said that, okay, using this auxiliary task, you can improve the main task because of regularization and blah blah blah. And then there were other, like these games and stuff like that, arcade games and stuff like that, wherein people were saying, if I were to train it on one task and then remove the last layer and then modify it to work on another task or a game in some sense, and then they figured out there was catastrophic forgetting. Like when it learned the second game, it forgot the first game, and so on and so forth. And then people started developing technologies to say, okay, how do you make sure that the network remembers all these games or all these tasks, and then sort of have a decent performance on all of them. There were also some tasks wherein if you were to do well on them, it would help some other tasks and so on. But then something beautiful happened in 2020 or so, 2019, 2020, with the T5 paper, wherein what they did was something beyond multitask. They unified all of those tasks in NLP. And what does that mean, right? Like, for instance, there are a lot of NLP tasks like entity recognition, NER, whatever, and then emotion recognition, sentiment recognition, blah, 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 right? They converted all of those tasks to a format of text input task description input, text output. All of those tasks were formatted this way, and then it's the same network which would perform all of these tasks. And that was in some sense the crux to me, which sort of opened this generalization toolkit, because the network was now exposed to a number of tasks, and then it helped once it's if you see one task and if you ask it to generalize to multiple tasks, that's difficult. Two tasks, three tasks, it might be slightly easier or difficult depending upon how they are. But if you look at 10 to 12 popular tasks, for it to generalize to another five or six related tasks is not so difficult, as you can sort of, by mathematical induction, so to speak. So I think that is what sort of unlocked that feature in my mind. And the same thing has happened in different fields, and you can go through that if that's interesting.
And the broader, philosophical
Oh
underpinning
yeah.
of language.
So language has been tied to intelligence, and this is well known. I mean, my ability to think about a concept depends upon my ability to articulate it in some sense as well. If I'm able to articulate it really well, I'm able to think about it really well. And there are several things that you probably can't even think about, which are also not represented in your language. So there is a very close relation between those two. And if you look at the ground truth for most of these modalities, text, right? I mean, essentially, the output is like for classification problems, it's text. For generation problems, it's of course depends on the modality. But for most of the classification problems, that there's a natural tying together of all of these modalities through language. So,
Yeah.
and that was another key. That is still another key factor which people exploit in order to unify to build these multimodal systems, where multimodal classification systems in some sense.
So basically, they have converted all kinds of activities into text input and
Yeah.
whatever the
So
activity.
exactly, right. So here's the point. Like very concrete example. If you take object detection, for instance, YOLO or whatever network, right? It would take an image and then it would basically throw out multiple labels, right? It would basically say this is this is a person, this is a cat, this is a dog, blah blah blah. In order to say that, you previously network had an explicit output layer which would emit a probability that something that given image is a person, given image is a cat. So that node would just emit a number, and based on that number you would basically say, oh, this node, I know by design it corresponds to cat. That that score, that probability is greater than zero point 0.9, and therefore I'm saying it's cat. But so that was how you would detect stuff. But the sort of the twist in the tail basically with LLMs is you can generate text. So if you now somehow hook up your image encoders or image representation network to your LLMs, the LLM can generate text, and that text can just be cat, right?
Yeah, yeah.
So
So,
instead of emitting the probability that something is a cat, you basically say that it's a cat.
so I think we've discussed this offline before. That do you think like variational autoencoders are like the toy models of LLMs? And you also pointed out last time that we don't even need the encoder anymore. It's just training and decoder. Okay, can you hit that point?
Yeah, let's clarify. I think we touched upon multiple things here. Variational autoencoders are sort of something different, I would say. Let's keep that aside. But if you were to interface different modalities with the so let's first zoom in on LLM. What is an LLM, right? In my mind, an LLM is a tokens to tokens transducer. It takes in some input tokens, it generates some output tokens. The output tokens may be longer than the input tokens. It could be shorter than the input tokens. Longer when you are generating summary, for instance, or if you are explaining, if you're giving an explanation, or if you're answering a question. Shorter when you're doing a classification problem or text classification mode. So anyway, it's essentially one abstraction for LLM is takes in input tokens, generates output tokens. Now, the LLMs that we know of, that are well trained, that are there available, online, are basically used to seeing textual tokens. They can identify these textual tokens. Now, one important question was, there is a significant amount of effort that goes into training these LLMs. Can I utilize these same trained LLM models and make them understand images and audio? If I were to do that, then I should do something at the input, right? Like I'm not touching the black box, the transducer black box. I've got to do something to the input. I've got to transform the images to a token space, the input space of the LLM, so that they can understand,
Okay.
right? So one way that people came up with doing that was, we have had image processing networks, image encoders, right? Let's encode that representation, put them into a space, but let's do some pre-training such that the image of a cat and the word cat, the embedding for the word cat, they both fall into proximal space in a particular embedding space.
Okay.
And
Okay.
the image representation of that cat is sort of far from dog or some other thing. So basically, using some contrastive learning approaches, you would you would train this image encoder and probably something in between, let's say a mapping network or so, which would take in this encoded representation of the image, transform it to a space that the LLMs can understand, and then decode from the LLM. So essentially, you have made the LLMs believe that what you're feeding is textual tokens, where in fact you're also feeding the image tokens in some sense, or image representations.
Okay. So you would say, except the fact that variational autoencoders has the encoder decoder as a architecture, the LLMs are a significant change in that, wherein they still have some architectural similarities, but it's significantly different. That's what you're broadly saying.
No, so variational autoencoding is basically um, a pre-training strategy in some sense, right? Like what happens in a variational autoencoder? If I so regular autoencoders, you give the input, you pass it through a bottleneck layer, you got to regenerate the same output, right? But if you were to represent the same out, if you were to generate the same output, they figured out that it's you're asking too much of the network. Like you have to generate all the gory details which are not required or whatever, and it's not generic enough. So you basically in the bottleneck layer you introduce a distribution, so to speak, and that's where the variational autoencoding sort of comes about. So that's a in some sense a pre-training strategy. But the LLMs in some sense are uh, as I said, token to token transducer, right? And you, variational autoencoding probably could be one way to sort of pre-train the network, but it's not the only way.
It's not the only one. Okay. So if you have to step back, and I know you're not an expert in each one of the domains like NLP or if you want to delve into the history of NLP algorithms to transformers or computer vision to transformers and audio to transformers. So if you have to, from your vantage point, if you have to summarize what the history has been in each one of these, and see as to where we stand at this point using transformers in each one of these, how would you put that across to a lay person?
Um, I, so as I said, so basically, I think the mantra has been figure out a way to use transformers in
Okay.
whatever modality you're using. In order to use transformers, basically you would need a sequence of embeddings. So the art has basically, to summarize all these fields, right? What they've done is NLP was already there. It had done a lot of work on these word embeddings, or even even representing these sentences which are not even words, sometimes subwords, or let's see about byte pair encoding and all that stuff. So there are very interesting representations of sentences which are sequences of embeddings or vectors in an NLP domain, and transformers were designed for that in some sense, to take that and sort of generate the output embeddings, sequence of embeddings. So the mantra for all the other fields has been, can you represent your input as a sequence of embeddings?
Okay. Okay.
And that in some sense has driven the reuse of the expertise in NLP in other fields like CV and so on. So you would definitely need some tricks of the trade to train these, right? Like, or basically to say how many what's the batch size should you use, what learning rate, what inside these transformer modules, what nonlinear functions to use, how to use the feed forward nets, if there is even in the attention, the super crucial part of self-attention or attention function. There are lots and lots of varieties and options that you could use, how to do that and stuff like that. Essentially, vision literature and audio literature, whatever, they didn't have to reinvent all of those wheels. They could just sit on top of what NLP had achieved and then go ahead.
And given this, how would you have to define what intelligence ought to mean? Or like you can probably get into what would you call intelligence and things of that nature. But rather than, let's say, the traditional notion of machine learning that you learn from experiences, uh, uh, or like you're probably using the same notion of learning from experiences as opposed to some rules that you would probably follow in a specific subdomain, which only works in, let's say, banking or finance or something like that, as opposed to a general idea of these concepts wherein, given any experience, you can use that experience to learn from it and generalize. So how would you consider, what would you consider or define intelligence as, given all the state of affairs of research that has emerged in this field?
So defining intelligence is a super tricky business. I mean, it's easier for me to define something, right? Like, but the point is, it's difficult to align this same definition of intelligence across all folks, all people, all different areas of research and so on. Typically, in such a scenario, what people do is they come up with an operational definition for what they're planning to do, and similar thing has been in machine learning as well. So operational definition is if you can learn from experience, and that is also very restrictive in some sense. And so they added, okay, it has to generalize, and when you say generalize, how long should it generalize? There was a beautiful Reddit thread that I read a few days back, wherein it was saying I think these folks were playing with GPT-4, and the question basically was that there's a glass door, and behind the glass door is basically a mirror. So you're standing in between the glass door and the mirror. You're looking into the mirror, and then on the other side of the glass door there is a blind person, and
Okay.
the door basically has pull written on it. Now, what would you tell that other person? What should you tell that other person? Should the other person be pulling the door or pushing the door? So, and
Obviously
essentially,
pulling, right? Because even though it's a mirror, regardless of what the surface is, you still follow
so it
what you
depends
see.
on which direction you have to pull, right? Like for instance, if you're seeing in the mirror and if you're able to see the pull sign, you've got to figure out whether it's towards your side or whether to his side. If the pull sign is towards you, you are supposed to pull it and he's supposed to push it.
Oh, he's seeing it as well. He has a sign as well. Oh,
But it's a blind person in some
oh,
sense.
it's a blind.
So
Oh, okay.
so if pull is written towards you, push would be written towards him. You cannot see that, of course.
Yeah.
So you can now sort of compound this problem several folds. If there was another mirror here and there and so on and so forth, it will change. You
Mm.
see that it even gets difficult for a human being to analyze this and then give a correct answer. Now, can GPT do that? So they tried it with GPT 3.5 Turbo or whatever, and it feels like it could get the one it didn't get it right. GPT-4 got it right for this one mirror situation, but once you put another mirror and so on, it sort of failed. Now, is this intelligence?
I given given the context, given what we know, I think this is a tricky problem to be in.
Right.
Regardless.
And this is also probably what kept Turing awake
Uh,
in his days. And Turing test is probably one of the least arguable tests in some sense to basically test whether something is intelligent or not. Uh, that said, that is also not foolproof. There is no foolproof way to say, okay, this is an intelligent system versus this is not. And that's the gray area. That's the interesting part about these times, because 20, 30 years back, there was no, we could easily say something is not intelligent very quickly. We are using Turing test and so on. But now the generative AI has made so much of leaps and which has come a long way, that it is getting hard to basically say what was generated by a human versus what is generated by an AI.
And given that context of a mirror image, if I have to extrapolate, which is totally, me coming these scenarios at the top of my head, if I were to have a couple of these, let's say GPT machines interacting with each other, and if they both see the pull sign, do they, if let's suppose alignment, all those problems have been solved, do they think like they have enough of a uh, idea of self-preservation that they cooperate and they pull together or they fight? Those
Oh,
questions are still much harder and murkier if you don't
absolutely. I
know
mean,
for sure whether the other agent is a friend or a foe.
yeah, you don't know that. And basically, this was just one example to scratch the surface, and there could be uncountably, infinitely many examples like these. And then it's not like we can generate bespoke solution for each of these examples or so, right? And in general, the idea of whether one machine trusts another machine is something different ball game altogether. In training, they're not trained that way yet. Very simply
Okay.
put, today they're not trained that way, but you could. I mean, that's catching up as well. Like in some sense, the adversarial learning, in some sense, was all about this, right? Like there would be a predictor network which would tell you whether what you've generated is fake versus not, and there would be generator network which would trying to, and its sole purpose is to deceive the or get through this predictor, and the whole purpose of the predictor is to sort of be smart enough to see what was generated versus not. This kind of this
Discriminator
kind of
generator
two-person
network.
game. Yeah, this kind of a two-person game, and then also this adversary in some sense. It's I think it's slowly also finding applications in LLM training. I mean, it's in, I haven't gone through the paper, but I recently saw that there are ways to improve a larger LLM using smaller LLMs and so on, and so forth. But having said that, that paper would probably only be about improving some metrics on some data sets and stuff like that. It's still not at this level of problem that we just discussed about this puzzle, so to speak, right? There are multiple challenges here. First of all, I think we are limited by our ability to evaluate these systems, in some sense. I mean, it's getting to a point where how do you even say that? Yeah. So if there is no ground truth, how would you say something is correct versus wrong? Sure, I mean our
Verification problem, essentially.
verification problem, and it's like our go-to for this was been human annotation. But in these problems, there are several humans who cannot solve this problem,
Yeah.
right? It's challenging for them, and so in that case, what do? How do you say something is right or wrong? That itself is difficult. So we are limited by our evaluation strategies. We are also, in some sense, limited by the fact that intelligence is something. If the moment you define intelligence, you want more out of it. It's
Yeah.
not a definition. It's not a closed group definition that you'd be happy with. So, but I think one good thing is I think we've always been pushing boundaries, and at least from the Turing test perspective, making it harder and harder for anybody to say that this is obviously you know generated by a machine versus.
Human. And if you have to define these, I mean, we could do a lot more definitions, but if you have to define the verification problem, the explainability problem, interpretability problem, how would you put them as the categories? Are they three categories? Then are they similarities? Are they intersections in the Venn diagrams?
They are. It depends on how we see this, right? Like so the interpretability, explainability basically comes from a that's coming from a different context in some sense. The idea, so basically what's happening is these machines are getting to a point where they're able to generate stuff like a human being. They're able to generate good text. They're able to generate good images and audio and stuff like that. So as humans, we are good in generating text. We are generating these images as artists or whatever, and so on. So slowly, what is happening is there is there's obviously been a dearth of workforce in a lot of fields for a long time now, right? Like there's so many fields which are facing challenges in hiring people, or that there are not many folks working and so on. So they would embrace this technology even if it is not perfect. And that has started to happen quite a few years ago, wherein people are trying to say, okay, let me use this technology, replace human beings, and sort of get something done if I'm not able to hire somebody or whatever. So you see that this technology is permeating the society now. It's left the laboratory, it's left your company or whatever. It's touching the lives of people on a daily basis as we speak. Now, once it touches the lives of people, what will happen is these are decision systems, right? You are going to make hard decisions based on what this machine generates. Once you make a hard decision, there would always be people impacted by it. There would be one school kid who would be denied entry into a school because of XYZ reasons, and another kid gets an entry into the system. There would be one person who would be automatically profiled, or targeted, or even inspected much more than another person. When this happens, the human intuition is, I want to know why did this happen to me? Why was my kid denied entry? Why am I being subjected to extra security check or whatever? Why am I not getting this job? All of these areas are where technology has permeated, is already helping people in some sense, to make the decision and so on. So in those cases, you need explainability. You need to explain the decisions that the machine is asking you to take, and that decision must be interpretable. You must be able to say, oh, I came to this decision because of XYZ reasons. Now you may ask, okay, are human decisions are always that way? Sort of. You can question the human being who took the decision, and he would basically say, imagine a judge sitting there making a decision, and he would basically say, based on these previous cases, based on this evidence, I'm doing this, blah blah blah. At least that. And the next question is, okay, are humans always perfect? Hell no, and that's the reason why our machines are not. A
Okay.
lot of biases that were present in all of the human decision makers have that's formed the training data for some of these systems, and now these systems are not perfect, are probably as bad as as some of the worst human beings were, and not as good as some of the really good human beings were. So it's somewhere there in that spectrum. um, but at least back then, when human was making a decision, you had a way to trace back and then blame somebody and make them pay for it, and then sort of change something. But with these machines, what are you going to do? Nobody understands why. An automatic driverless car goes and hits somebody. Who are you going to blame,
Yeah,
right?
yeah. And
And this is a
also,
legal battle, and there are some ways to do it. I'm not saying that there are no ways to do it. It's just that we are at a sort of a nascent part of this technology where all of these have to be debated, discussed, and figured out.
yeah, yeah. So given
So
that,
that's exchangeability, explainability, and interpretability. And your other point was verification in some sense. So verification, I would say, is largely, I don't want to call it a lab exercise, but it is in some sense, because even before you deploy this technology to impact people, that's when you need to do rigorous verification of this work and stuff like that. Not after, and after deployment, you need to do health monitoring to verify that the quality still remains, data shift, model drift, all of that. But a lot of verification is sort of off, like front loaded, wherein even before deployment you do it. But explainability and interpretation is something that needs to happen after deployment as well. It has to work even then.
yeah. And given all this, I think your work should be really exciting. Yeah, assuming that you're in an interesting team which has an interesting acronym, an interesting company that you work with. Let's. I would prefer not to name the company at all, given the context. But if you have to say what would a typical week look like,
Yeah,
and
I
yeah,
mean, yeah, I basically work as an applied scientist, and what this means, I was getting asked this question quite a lot as well. But essentially, what this means is, as a as a as a person who works on science, like from graduate school to so on, what we basically do: read papers, implement some techniques, find some interesting ideas, we'll have our own passions and our own problems. So we either get inspired to think about it in a different way or come up with our own technique, do that, show that it's working on a proof of concept, some data set, publish a paper, be done in some sense, right? That's sort of the span in some sense. Or you can continue working on that problem and so on and so forth. That's what happens in academia and so on. In industry, I think the basically uh, just a bit of a detour. I was reading something about this. There was this MIT professor, historian, who was researching on Indian politics, Indian freedom struggle, and so on. And there was this popular question of, did we get freedom from Mahatma Gandhi, or how effective Mahatma Gandhi was? It could be a controversial topic. I'm not going to touch upon it, but I think the author was made a very interesting point. He said, whenever you have to inspect the source of truth in history, follow the money trail.
Yeah, yeah.
Economy will give you a lot of truth a lot of times. If we take that notion for a while, then you basically see that the source of funding for academia and industry are different. In industry, and this is also another thing that Gandhi basically said, you're customer obsessed. So,
Gandhi said that?
oh yeah, Charaka, right? I mean, they were in the sense that he didn't say the
I
exact
mean,
words, but the point was that every
being
businessman should
empathetic.
empathetic towards the customer that you are. So so essentially, if you look at the industry, right, where the money comes from is basically by selling products, impacting customers, and so on. So as an applied scientist working in an industry, one has to really think about, this is a great piece of technology, but is it scalable? Can I deploy this? And the point is it going to be impactful to the customers? And does it scale such that you can sort of sustain the business around this? Sustain. So a lot of people think about it as making money. Sure, it's making money, but the crux of the part is you have to sustain a business, and sustaining a business is not a joke.
Yeah.
So it's an equilibrium. You have to make money, you have to shell out some money, you have to make money, and then you have to sustain it so that you can impact people over a longer period of time. So therefore, there is an added element to it, wherein you basically have to see, and then you can't just work on ivory tower research problems, right? You can't say, okay, I love this problem, I want to see, you know, I want to just go ahead and investigate this problem. You basically have to justify, if you were to investigate that problem, what are you going to get out of it?
Yeah.
Right. So you have to justify that.
This is the old academic alignment problem.
Yeah.
What to
So
work on.
yeah, and this is a long context to basically frame my daily work or whatever. But essentially, it's got to do with understanding technology and solutions that can impact people that you're working with, like specific to that company, what the company is interested in, aligning your interest towards that company in some sense, and then making sure that you're developing solutions to utilizing the company's. It's a machine, right? Like, you've got to utilize some of it to impact people. What are those problems? And then what are the so that's there is a social problem. Now you need to break that social problem into a technical problem that you can solve, which will unlock that social problem for you, or a particular solution for that social problem, basically. So identifying that technical problem, and then again, all of the things about your PhD training would sort of come in, basically to say, okay, this is the technical problem. What are the different approaches that I can use? Do I need to invent a new approach, versus can I use something existing? Is there an existing solution which already solves all these problems? The most important point here is constraints. The whole point is not solving an unconstrained optimization problem, but it's constraints, and those constraints are basically what is specific to your business. You
Correct.
understanding those constraints and operating within that realm is what will finally decide the solution,
Yeah.
right? So essentially, if you look at it, what we have done is something like what we talked about transformers and NLP, right? Transformers worked great in NLP. The PhD training worked well in some sense. So we basically boiled down the industry problem to an academic problem, solve it, and then take it back to the industry in some sense. So
Yeah, I think just
So
to give some bearings to this whole stream of argument is in the startup ecosystem. This whole concept is called value proposition. Value proposition is what are you building? Who are your consumers? What's the status quo? What's the value addition that you bring to the table, and how much is the value addition compared to the status quo? If it is not more than 4x, then 4x more than 400 times better than, I won't say 400% better than the current status quo. It's not even economically viable.
viable,
Not, yeah.
you wouldn't
So
even touch
this,
your, yeah.
yeah. So what essentially you explained in a broader sense is what startups essentially end up doing, defining
Yep.
what your value proposition is and be clear. And also the thing that you talked about in terms of socially, you look at societal problems. I think you're looking at consumer behavior, and you want a frequently occurring consumer behavior disrupting which you create significant value.
Correct.
Yeah.
And it takes an eye to spot those problems. And I'm not saying that an applied scientist basically identifies all these problems. Hell no. A lot of these times, problems are basically identified by program managers, by TPMs, by managers, whoever is sort of interacting closely with customers or whatever, right? Like so, and so the point is that an applied scientist cannot lock himself or herself in a
Box, so to
in an
speak.
anechoic chamber, so to speak, because we
Okay.
are talking about audio. But basically, we have to interact with all of these people, right? Like all of these folks from different expertise, from different teams. So you see that there is a cross collaboration in the technical field itself. One has to talk to NLP, computer vision, and so on and so forth, and stuff like that. And apart from that, we also have to talk to TPMs, PMs, and so on to sort of get an understanding of what really is a good problem to solve. This is not at all easier task. It's very challenging, so to speak, to sort of get an understanding of, okay, this is the problem to solve, and this is not the problem to solve. That getting that clarity takes a lot of time. Um,
Okay. And
and
have you experienced, if I may ask, since you're part of that organization, Mr. Bezos is very famous for writing memos and saying no to presentations. Do you experience that? And how was your
oh
experience?
yes, very first day, from the very first day. So essentially, I mean, I was passionate about presentations and stuff like that, right? So I was not a fan of PowerPoint, but I'm a fan of Keynote. But still, I was all set for using those tools at my disposition to make an impactful pitch, so to speak. I walk in, and this has been the experience of most people. My very first meeting, 30 minutes, nobody's talking. Everyone is just reading. It's absolute silence,
I know.
right? So and it took me a while to understand what what is the problem to which that is a solution. And slowly I realized that some people are very charismatic in their presentation, and some people, for nuts, they cannot present an idea in PowerPoint. um, but all of these people are going to be there in the industry. There's not just, and the industry is not going to hire somebody because they're an excellent presenter, or they're not good presenters or whatever, right? Like there are going to be all kinds of people
Two
everywhere.
ends of the spectrum. One is extremely detailed oriented, another one is
Yeah,
extremely charismatic, and
yeah,
everybody is in between somewhere.
in between. And the point is, it doesn't matter how charismatic you are, it doesn't matter how bad you are, as long as you are building a sustainable technology, you are bringing money to the company, and you are building a product that people love.
Yeah.
The most important part for me was to understand that charismatic speaker doesn't always mean that they are recommending a solution that will be all of these qualities.
You
And a
still have
bad
to.
presenter, yeah, and a bad presenter doesn't mean that their idea is necessarily bad and it's not so scalable and stuff like that. So you would, a lot of people, a lot of times you would just miss out on the great ideas that these people had, they were who were not able to present well or whatever. And we would also miss the really bad ideas because somebody presented it beautifully. So in order, and these are costly affairs for business, right? You can't afford to just lose business based off of that. So I think one great way was, instead of having one mind go at that depth, if you had multiple people take a look at that depth at which that idea is being presented, that would help us mitigate some of these risks. And I feel like for that particular problem, the solution of having a written document where people read and align and say okay to makes a lot of sense.
It's basically the promise that the written word is more valuable or worthy or more has more weight than, let's say, the
Sure.
spoken word. That's the
Sure, and
broad
then it's
theme.
traceability, and it's not like I can't go back tomorrow and say I never said that. It's there,
Yeah,
it's there for posterity, and it's like and that commitment is there. That sense of ownership and responsibility is there, and basically, I will. It's also the human nature, right? Since time immemorial, it's very very difficult to write a concise doc, and it's very even to put a word, you think twice, you think more than you would think before uttering a word.
yeah,
There are a few people who are extremely committed to their word. They don't take back their spoken word, but not everyone is like that. But most of the people definitely do think more when writing. And the the gift of writing is basically you have the power of editing.
yeah,
The curse of speaking is basically you can't go back and change it in some
yeah.
sense.
That is true. And one of the points that I noticed when I was just reading about, let's say, the company and you specifically was you do refer to the internal legal counsels every time you build a product or a POC. And on top of it, I also wanted to ask in a typical year, one entire calendar year, how many POCs would you end up working on if you have to have
Oh,
an average number, and how many actually make it? The reason for
it's a,
asking this is to basically tell people, like, even within a big industry, there are a lot of trial and error and there are a lot of failures.
absolutely, absolutely. I
If
mean,
you want to draw on that,
yeah, absolutely. I mean, it's a huge bottleneck, so to speak. Like you have a lot of ideas that you consider. There are a subset of ideas that you implement, and even very few of those get into a product and stuff like that. So essentially, I mean, again, as I said, um, nobody in this world at the moment has a vision that. Well, I know a lot of people think, okay, Steve Jobs may have had it, or Bill Gates may have had it, or whatever. They definitely had a very strong intuition. They had a higher prior. They had a good conviction and belief that something is going to work, but it was not a certainty till it was a certainty, right? So till they launched it, and then so there are a couple of things here. First thing is, before you launch a technology, you don't know how good or bad it's going to be, and also you can't always use this framework of deploying a technology and seeing whether it works or not, because it's too expensive and not scalable. So because of these two endpoints, right? So you now have to, because of these trade-offs, you now have to figure out some stuff based on your intuition and the market and the customer requirements and stuff like that. You've got to figure out what is impactful, make a guess, and also figure out a way to narrow down some of the bad ones, filter out some of the bad ones without actually going ahead and deploying it. You may also have to scrape some of the project. There are tons of projects that Amazon has come up with, and which they tested the temperature on, it didn't work, scale back. So there are a lot of things that we try, and some things work. And there was a beautiful story to drive home this point. This was never clear to me, right? Like as a grad student, you may have heard it. It's a pretty popular one. It was an art class, right? So the professor walks in and he divides the class of 100 people or whatever into two groups. The first 50 were asked to build to make the best pot that they can, right? You can only make one. You have to make the best one, right?
okay,
The other group were asked to build as many pots as they can. And finally, each group were to submit their pot or whatever, the best pot or whatever, and then the professor would say which one is better. Now, can you guess which was better?
to one part.
No, basically the group which made a lot of pots were the ones who were who were able to make a better pot, because they tried and tried and tried, and with their trial they just got it right. But in the other group, they were theorizing as to this may be better, that may be better, and they just did one. It was obviously not better, and they couldn't go back.
This is the theory of diversification. You diversify and iterate quickly. And I think Sam Altman said something on these lines, the kind of teams which iterate between products quickly so that they get the feedback loop in
Yeah,
place win quite a bit. So,
and quite a
I
bit.
mean, from the
There's a lot of
analogy, this is the
there are a
same
lot of things
analogy,
to
right?
learn. There's a lot of things to learn from this, right? Like first of all, the thing is we can't we can't put the constraint that every idea that we work on gets deployed, and at the same time we cannot get discouraged by saying, okay, this idea did not get deployed, so the point is we've got to keep trying. And the other thing is the more we try, the better we get at it. And there are a number of people have expressed this in different ways. Like for instance, there is one author I sort of like, James Clear. One of his famous books is Atomic Habits, wherein he basically says, you he's a good writer. He's also he basically says that you have to write a lot to basically scrape off all of the garbage and then to get that gold idea out, right?
The
So you can't
sloppiness in writing is sort of ebbed out so
have
that you
doubt.
eventually
Yeah,
get to the whatever thunder.
and different writing styles. The art, what is that called? The artist's block or something like that, right? Like the mind block where they're not able to
Artist
produce
block.
anything.
Yeah. Yeah.
So
Writer's
the
block, I think.
writer's block and stuff. So basically, the point is to keep producing something so that that comes out. It's not that it's there at the top of your head. It's there somewhere. Got to get it out. And I think another person who sort of there's this author of this book. I forgot the author's name, but the name of the book is Lean Startup, I think,
Lean startup.
which
Yeah.
apparently the moral of the story of that book as well is that you've got to figure out a way to fail faster. Howard Hughes also probably had the same vision in some sense when he was sort of these making these. So essentially, in all of these technology, why is this suddenly coming out? Because it's no longer the case that there is one person in the world who understands what the world needs.
Yeah.
We don't. I think it's okay to accept that we don't know what the world. We don't know what our customers want, like perfectly. So it's okay to test temperature very quickly, get their feedback. The crucial part is get the feedback, iterate, get the feedback and iterate. So
So this old adage that you have to focus on one thing, because if you do multitasking or if you do many things, you're not. Some people are of the view, which is, I think, the what I see is this is a huge dichotomy in terms of people working in different industries. People who work in tech understand this concept better than people who work in, let's say, historically non-technology fields like oil and gas or any industry which has like a traditional monopoly attached to it. They're of the view that you have to hyper specialize and do one thing and you don't have to touch anything else. And people in technology are of the view that you try all the things, you bring all your tools, try your products, whatever works, you stick with it. I mean,
oh yeah.
is that a bias basically got to do with being in the industry? I mean, you're in a monopoly industry like oil and gas. It always work. It always will work. So we don't change anything. We hyper specialize. We get the specialist in.
Hmm. It's hard to comment from outside. I mean I don't understand the oil and natural gas industry as well to sort of understand. But again, I think I would have to still base my response on a very interesting book that I read. I have to bring this up. Called it's a book called Range. The last name of the author is Epstein. I forget the first name, but in this, the author basically says why it's actually bad to hyper specialize. I had a tough time reading this book. All my life, every single person I looked up to, every single teacher of mine, they've always said, you have to be good at depth. You have to go deep in one area, you have to be really good at it. That's what I've been told all the time, right? And I had a different postdoc experience as well. Like, maybe it's worthwhile to touch upon later, but this book kept saying why generalists are much better in this world. And the premise of the book is basically that, again, as I said, uncertainty. If you know for sure that this is the field that's going to kick off in the next 5 to 10 years, and this is the only field that is there, it might be okay. Even then, he'll argue that why generalists have a different viewpoint, but that might be okay for hyper specialization. But in a world where it's uncertain, which is typically the world that we are in, a lot of things are uncertain. Like tomorrow, somebody may invent something that may disrupt your life. Happened in 2017, right? People who were over focusing on RNNs, LSTMs, and stuff like that wake up next morning, Transformers. It didn't catch up in like next day. It took about some time, but still they had to change. But and what this author basically says is, it's good to be specialized in one area, but jump to another area. Don't stick to that area. Like, go to another area wherein you will now basically see how beautifully you will be able to make connections to the area that you're specializing in and the new area that you're working in. And that is the source of new ideas in that field. That's the influx of new ideas. That's when you can make a contribution. If you're in the same area for a long time, you basically cannot offer anything new on a regular basis.
Okay.
Uh, and basically, he was also trying to convince his readers who are late bloomers to not feel bad. Uh, he the the beautiful example that he gives, which is like etched in my memory, is the example of uh, 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 what's this painter's name, uh, who did a self portrait. Uh, forget his name. Um,
Van Gogh.
Van Gogh, yeah. Example of Van Gogh. Van Gogh basically tried a ton of things. All his great paintings apparently were painted in the last 1.5 years of his life.
Hmm. Okay.
He was, and like he was super chaotic. He tried a bunch of things in his teens and stuff like that. And yeah, towards the end of his life, he didn't know, probably the end of his life or whatever, but that's when he started these paintings, and all of those were his greatest outcomes were that. So it's not like he started painting since he was 1 year old and then he
Yeah,
was good
yeah,
at
yeah.
it. Same thing. He also talks about Roger Federer. I think Roger Federer initially was playing football, interested in that, and then sort of switched over to tennis, sort of relatively lately compared to some of the other prodigies or whatever. So basically, he was making a point that if you are starting, if you feel like you're late to the party, don't feel so. You probably have something beautiful to bring to the world.
Offer. Yeah. I mean, given this, I had a bunch of things while you were speaking. I mean, let's touch upon the nature nurture thing that we talked offline. Given the fact that we live in the age that we live in, and the way people are getting verified as to whether their skill set is valued, if it makes sense or not to the current world. Given all these questions are there, do you think, like, where would you put your foot down and say this is the amount of nature that is involved in a person's ability, and this is the amount of nurture that is involved in a person's ability?
I would refrain from putting any numbers on that, simply because it's it's a choice. It's a moment to moment choice, right? Like, I mean, by default, I'm predisposed to doing some things. I want to do X. My predisposition can help me go towards X, may not. But the key point is awareness. So basically, me being aware that my predisposition is not going to take me from Y to X, and I need something else, and my willingness to do that something else is where nurture is going to come in. The world is in a beautiful place right now where anybody on this planet Earth have access to knowledge, unlike historically speaking. Like, common man did not have this much access to so much of knowledge ever in any historical period of time.
Yeah,
So if you want to learn, this is a great period of time. If we don't learn something, it's on us, in my point of view. So the nature versus nurture thing is, it's I wouldn't even say it is nature versus nurture. The way it is even put across is, to my mind, is um, is is oxymoronic in some sense, I would say, because no matter what you do, there is some part of that journey is by your nature, and some part is going to be through nurture. You've got to change, right? You've got to learn new skills. You've got to build something, build a new ability, acquire a new ability, and not just rely on what you're genetically good at.
yeah.
So
The intellectual life of this basic debate has got to do with Charles Murray's book, The Bell Curve, which basically essentially created a huge uproar of sorts in academia and elsewhere, not mostly in academia and popular culture. But that has got to do with the fact that even though it's always a mixture between the two, if you have to design a social system of education and funding primary education or early child care or funding graduate school, you have a choice. Eventually, a social planner or anybody of that sort has a choice in allocating resources. Given that, that's what I was looking for. Given how much weight you put in, what kind of society you want to design wherein it's optimal for everybody. That's what I was aiming for. Given what you know, how would you plan it if you were to be the social planner of the world? Or let's say some small part.
It's definitely a tough job, and I'm not sure I would really I mean it's it's a super important job and definitely a tough job. My physics teacher, I remember, he would always say, you can't impress the world with just one rule or one algorithm. No single one thing can impress the world. So I think rightfully so, the world has moved towards customization. So it's no long. I don't think we need to think about one system, one mechanism, one way that would impress everyone. No, I feel like that's a wrong paradigm to be operating in. My mental model is, how can I empower people to learn the way they want to learn? How can we create technology and empower people to make this self-sustainable in some sense? To me, this system of schooling, right, is in some sense good in terms of social and stuff like that. And a lot of times it's sort of not that great because it's not optimized towards one's learning at all. Every human being is in some sense different. They bring different things to the table. They're so so I feel like a system which would empower each person to basically learn the way they want to learn. And so the emphasis must be on, in some sense, the goal, the end goal of it, but not really the journey. The same target can have multiple ways of doing it, and I don't think one way is necessarily better than the other.
Okay, given that, would you want to contrast, let's say, uh, you know, habits, learnings from the different educational systems you were part of? I think you did graduate school in India, postdoc in US, and then work in US. So, how do you contrast countries as places of work or places of, let's say, study? Let's take places of study, and then in
Yeah.
terms of cultural differences, attitudinal differences, because people might want to glean from those points and say, "Oh,
I mean,
it's worthy." And how much of it is? Had you gone to Europe to do postdoc?
yeah, yeah.
How
I
how
always
would
got.
that turn out? Or what's the
I,
counterfactual if you have to play it on your own mind?
again, I may have a semi-controversial view on this. I again feel
It's always the
that
better.
the cultural aspect of it could probably be driven by the finance aspect of it. Let me take a step back and see, sort of explain where I'm coming from. In India, if you see, a graduate student in the premier institutes is paid by the government of India. The payment is contingent upon him being qualified, selected, and not on the project. The advisor does not have to get the grant for each of the PhD student, and then it's not that somebody is taking a look at that project and assessing whether that project is gonna has any scope, like merit in it and stuff like that, and then continue. It's not that you're given a flat, right? In the US, predominantly, most of the universities, it's not the case. The funding for the student comes from a project that the advisor has written a proposal for. Somebody in the government or in a company or whatever is sitting and carefully, not like reading through those proposals and making a judgment to say whether it's impactful or not. Now, what this does, very just this simple change, what it does is, in India, maybe the student is encouraged to think about problem that he finds interesting. They can spend time on it for 5 years, which is a remarkably philosophical experience, right? Like, there is no other period of time, at least for me, right? I did my PhD in India. There was no other educational system where I had to spend so much of time with myself and be okay with that. And also, sort of, it gave me a platform to understand myself philosophically and so on. So naturally, I was also spending some time on Advaita, learning Vedanta and all that stuff. In addition to the technical, fields of signal processing and machine learning. Um, I'm not saying that a PhD student in US would not do that. In fact, a lot of people do that, and much more than what I did. But the point is, they are not at liberty to choose the problem that they are going to spend most of their time on. They still have the freedom to work on the problem when they do have time, but they also have to, utilize most of their time typically on on the problem for which the grant is sort of written and so on. Sometimes it aligns, so people do great. Sometimes it doesn't align with their interest or in their problems. So what it does is, at some point, your educational system is forcing you towards thinking about what's the value about about the technology that you're developing. Think about that and then develop. And in other case, it's not all bad, right? Like, it's all trade-offs, right? In other case, it's just trying to encourage you to think about a fundamentally good problem or whatever. Now, is there one system which is really good, which is really bad? Absolutely not. Each of them have their own benefits and so on, and it depends on what is sustainable and all that stuff. But to give you an example, like, the Indian system of this thing is not at all bad in some sense. Srinivas Ramanujan basically invented one type of this basically was I got this information from a book by Robert Canigill, the man who knew infinity, right? The movie was also come out of it, but
Yeah.
from the book is like brilliant. Um, Srinivas Ramanujan invented a particular infinite series. He just did it for the fun of it. He was not worried about where it's applied and stuff like that. And it turns out that decades later, people found that a particular cancer cell basically grows in that, but follows that series.
Yeah.
He did not work backwards from the cancer problem. He just did it, right? So basically, there is no one way to solve a problem. You can work backwards from the problem, or you can work forwards to another problem, and the solution to that problem is a solution to this problem, and so on. A lot of things can happen. So there's no, again, making hard, fast rules to say it should be this way versus should be that way is necessarily bad. But having that freedom in some sense is good, I feel. Now, this debate has sort of surfaced in multiple different other avenues. There was this book by Hardy, G.H. Hardy, I think, which was
Yeah.
also,
Hardy. Yeah.
it was a I love that person because he was able to express his thoughts so well in words. He would also talk about applied versus not applied, and he was strongly on
Yeah.
not applied, right?
Yeah. Yeah.
And there was another book written by um, it was called Pasture's Quadrant.
Okay.
So basically, if I can spend 5 more minutes on that, it's a in the post World War USA, one of the bigger problems was what kind of research project should the government fund? Should it be fundamental problems? Should it be applied problems? Right. And
Mhm.
before the World War II, uh, there was this person who wrote a proposal. I forget his name. I forget his name. I can come back. But he was basically saying fundamental is good. Fundamental, you should sort of, and he continued that for the
When you say
uh,
fundamental, you're talking about pure research for its own
pure
purpose.
research for
There
its
is
own,
not.
without
You're
any
not worried about the value it
application.
adds to society. Yeah.
Right. And in this book, in Pastor's Quadrant, the author basically says you can think of this entire grid as a four quadrant space. One is Bohr's quadrant, right? Let's say is basically fundamental problems and so on. The other quadrant is the Edison's quadrant, where it's completely industrial. I'm going to try the hell out of it,
Yeah.
work backwards from the problem and do it. But he was advocating for this third quadrant, which he felt was more beautiful, which was Pasteur's quadrant. And why Pasteur is because Louis Pasteur, I mean, he he worked backwards from a problem and created an entire scientific field out of it. Microbiology apparently was his work in some sense. And that he started working on that problem because at that point of time, there was this problem with cow's milk. He wanted to figure out what that, I forget the details, but essentially pasteurization came about because he was studying on that problem. The reason why he started out that problem, because in his town, that was basically the sort of the problem. So what the author was basically trying to say is, your research need not always be fundamental. With some effort, it can also be applied. It doesn't, just because it's applied doesn't mean it's fundamental, and just because it's fundamental it doesn't mean it's applied. It Every researcher should walk that extra step to make sure that they find intersection between fundamental versus applied and so on. It's very challenging. The book is very inspiring, but it's really it's a hard problem. It's a moment to moment again choice that one needs to make. Uh, so so yeah, that
Yeah, I think the corollary, I mean, if I may say so, it might be even more controversial. The corollary of what you essentially pointed out to is India produces great researchers who can come and work in the US, which eventually ends up being a great win-win for both systems. But I don't know Indian government would take that openly. But just to give you a heads up, right? Like, I mean, you might probably know this. The NSF funding here is probably $10 billion. So I look at the NSF grantees just to see where are they funding right now. What's the US government's fund? That's a good, let's say, mixture of ideas that they think will have value. And someone would have done a detailed, analysis saying that, okay, in terms of like NSF funding in math, right? Where are they putting all the money? They're putting money on things that they think are useful. And they are denying there are 40,000 applications, 10,000 get picked. So those 30,000 applications did have merit, but didn't make it for whatever reason. But that's a good exercise that they're doing at a national level. And all this information is out there. But the
yeah,
corollary, as it stands, because your funding is not tied to a particular problem, you end up developing yourself in an extremely good way. That also makes it very amenable, economically speaking, in the real
sure.
world that we live in. People
I
go
mean,
about.
so we just talked about the good aspects of both. We didn't talk about the other aspects, right? Like, for instance, there are tons of students who don't like that, who want to be given a problem and they don't enjoy not being given a problem or to find a problem of their own. And that can also lead them astray into developing some problems which are inconsequential, blah blah blah. So those are some of the problems there in India, and some of the problems here. I think we talked about it basically to say I may not necessarily be inclined or motivated or even capable of working on a grant in the topic that I like.
Yeah. And also, this kind of scenario, you might, if you're working on something on your own, very remotely, you might miss a big wave that has happened in the world,
Of
right?
course, of course,
But
and it's
in
happened
this
a lot.
system, you would never miss any waves because you're looking for waves constantly. You're looking for,
Sure,
yeah,
sure. I mean, you will be part of the wave. And next question is that good or bad?
yeah,
Of course, there is nothing good or bad, but is that so for some people it's great. I want to be part of the wave, and for some people I want to create the wave,
yeah,
and for some people it might be I don't care about the wave. So
yeah. One,
so it depends. It again depends on one's own on nature
yeah.
and what they want to nurture. So
And also, I find that you're also remarkably well read. So let's touch upon some of the books that you told me previously that are interesting to you. Weapons of Math Destruction. I think Kathy O'Neill, is it? Yeah. So why is it? What's so interesting about that book, and what did you glean from it? I
I
mean,
mean,
it's
I,
probably, if I understand it, math, the demerits of math, the broad theme, but you can expand on it
no,
properly.
it's sort of a nice wordplay about mass destruction. Is it's sort of well known and stuff like that, and nobody would associate math with the destruction. At the time I read it, I felt like I was very insensitive to where my what I do would land. But that book cautioned me in some sense to think about that, to basically say the day-to-day decisions that I was making and stuff like that, that I had to be careful. And so this was back in I read this a few years ago, but essentially the book basically is talking about the f- something that we touched upon, right? Like this technology is permeating society. It's finding use in prison system, in schooling, in education, in job market finding, job applicants, healthcare, and all that stuff, right? Like in all these places. And the part at that point of time, at least, severely flawed systems unknowingly were deployed. It's not that somebody did it on purpose, but it's just that even without knowing, somebody did it. But the point is, people who are using this technology were ignorant, thinking that this is God-given truth, and they used it as such. And there are demerits. There are serious repercussions of using technology that way, especially imperfect technology. Specifically, if the people who are using this technology do not have that insight that this need not be the ground truth in some sense. So I think to me that book was really powerful because it clearly laid out how technology impacts people. The deployed technology, sort of in general impacts people. Um, it has a bit of a negative connotation towards the AI research and all that stuff. Kathy she's a data scientist, and she doesn't mean it that way. But all I'm trying to say is that the researcher side of the story is missing in that book.
Yeah.
In the sense that a naive reader reading that book might be like, oh man, these researchers are sort of
Taking
uh,
taxpayer money and having a lot
taking
of
taxpayer
fun.
money, and they're so reckless. They're so it feels like they are they may turn out to be bad actors. They may appear as bad actors to a naive reader. I feel like another book that I recently read,
Freakonomics would
Alignment.
be a nice, on the spectrum of researchers showing acts of valor. I think Freakonomics would be a great book because they're the researchers going and living in some gangs to collect just data. That just shows the opposite end of the spectrum of the story of a researcher. I think Kathy might have been probably, let's say the basket of disgruntled group wherein like they think all academia is like they're just having too much fun kind of
I,
group.
I don't know. I don't want to blame Kathy for that. Maybe at that. So it's also, every book is a tool. In some sense, is addressing a particular issue. So maybe it was timely. Maybe that was needed at that point, for a particular point of time. But my notes from it basically was that it was largely one-sided. Largely one-sided to a good degree. It was good in the sense that it was representing the side that was whose story was not told.
Okay. Okay.
So it might be a timely effort in that sense. So I don't blame her for her choice or whatever. So and it's anyway, I don't know her in person, but so but but as a
Another
book,
book you were referring to. Yeah, go
was
ahead.
alignment problem. It was basically alignment problem, and this problem was really nice because it's not that researchers are heroes or villains or whatever. They're somewhere in between. They're humans. This book basically shows that. It basically is an interview of the researchers. So basically, the author's starting point is, in some sense, weapons of mass destruction, right? Like basically how technology is affecting. And then the author sort of walks with the researchers to say, how was it developed in the first place? And then you will see that it's very, very difficult to build a socially fair system. The notion of fairness is, again, like intelligence or whatever, is not frequently agreed upon.
Yep.
And researchers have to get started somewhere and do something somewhere. So this was a more balanced book in some sense, in my mind. And the other book was Atlas of AI. Kathy
Kate
Crawford, Kate Crawford, I think.
Kate Crawford, Power,
That was
Politics,
also
and Planetary
heavily
Costs of AI.
heavily one-sided, heavily one-sided. But I think yeah. So
And the general theme of the book is essentially the
again, weapons of mass
problems of
destruction.
AI.
Yes.
And I think recently in one of the conferences, there is this guy by the name Andrew Lowe. I think he touched upon the benefits and eventually it was a panel and they asked, what are the merits of AI? And if you have to give a rating between 0 to 10, how would society transform itself? So is it, and he had a very interesting view. He said it's +10 and -10, and I don't know where it is, but I would give both the values because his thesis was there is more propensity to create fake news as a result of this. And
Yep.
the upside is obviously education systems can be bettered and uniformized and generalized to a fair
Yeah,
extent.
there's, like any technology, it has potential for all kinds of applications. Whether you use it to do good for your to other people or to inflict harm on other people is that is there. So that choice is there. But I hope a lot of people will use it to sort of uh, at least not harm anybody else.
So how do you decide what book to read? If you have to, the next time, what do you consider an interesting book? By looking at the label, how do you decide whether to buy the book or read the book, or how do you decide the
To
criteria
me,
for a good book without reading it?
to me, recommendations play a big role. I mean, I think there was just one book that I picked up on my own because I sort of like the title and the thesis. That was probably Deep Work by Cal Newport. But as I was reading that book, I got some recommendations for some other books and so on, and then I picked up one of those, which also sort of was sort of interesting. And I was also sort of simultaneously following some of the other authors and stuff like that. So, I mean, long story short, I'm basically sort of I like this aspect of meaning in life, so I sort of subscribe to Viktor Frankl's notion of that that meaning is sort of what we create, what drives our lives and so on. So I was following what books are towards that end and stuff like that. There's something called a meaning movement. There is a nice website where there are some books, and I got some recommendations from there. So I used to maintain a list of books that I want to read where I come up with. Like I'm talking to you, and you mentioned Freakonomics is something that I've not read, but I made a note to say, okay, I should read this book based on a nice anecdote that you shared. Similarly, there are a few other friends, they would have read some books and they give me some recommendations, and I sort of enter it into my list. And then, but and it was, sometimes I'm reading something and like this Pastor's Quadrant, I think, was recommended by Christopher Bishop in one of his talks in one of the conferences, right? So, and the point is, I don't feel like reading any kind of book at any point of time, right? It's not arbitrary. At some point of time, I'm in a particular mental zone where I feel like I need this kind of a material and so on. And based off of that, I can sort of pick one and then sort of read. Weapons of Math Destruction, I picked it up because I started feeling that, okay, I sort of read some article somewhere which at least made that issue more real to me, and I wanted some more information on that, so it was natural to sort of go there. So basically, I have a list of books, and I basically choose it based on my mental disposition in some sense, that I want to learn something and stuff like that.
And going back, if you were always fascinated with extracting information from audio signals, that was your core domain. You wrote papers in that. So, can you tell me as to why that became an intellectual curiosity? Probably because you chose that field. You liked signals and systems properly. So, can you give me some brief history?
Yeah, that's I'm also curious to understand that in some sense, but I would say, I think growing up from my undergrad days, I was for some reason like very much interested in signals and systems and signal processing and stuff like that. That was something that was very close to my heart. Probably, my father would always say that, to come under the influence of a good teacher or a good book, one must be really lucky and so on. So I really liked Oppenheim's book. He was like my hero in some sense in undergrad days. So I love signals and systems. And I also like VLSI because my cousin, who I look up to a lot, like he was in that hard sort of this sort of a hardware, that kind of a sort of VLSI system design and chip designing and stuff like that. So I also had a sort of an inclination towards that, inspired by him. So when I started to do my PhD, I was more towards the chip circuits, analog circuits, digital circuits kind of a thing. And when I went there, the opportunity, I was supposed to do a PhD with one advisor, but I think it so happened that he was that that the position that I got offered to was a joint collaboration with another professor who was doing signal processing. And for some reason, this professor who was working on VLSI maxed out or whatever, he was not able to guide me, and I switched to signal processing. I thought, okay, this is my. I also like signal processing, so let's work on that. And this other professor was basically mostly into audio signal processing and machine learning and so on. That was my PhD advisor, Dr. TV Srinivas. So and as and when I believe that at least I'm a type of a person where if I start investing more and more time on a particular topic, I get attracted to it and stuff like that. And it's natural for a lot of people, I think. If they invest more time and energy into something, start liking it. So I invested more time and energy into audio and stuff like that, and started slowly sort of liking it and stuff like that. And finally, at one point, sometime in 2011 or so, I was working with a group of interns, and suddenly it, we coined this problem. We were doing something about speaker ID and stuff like that. And at some discussion somewhere, it felt like there's so much more information in audio. It's just a 1D signal. If you were to plot it against time, it's variation of voltage with time, right? But when you listen to it, you can uncover meaning at the level of what was spoken, speech recognition, who spoke, speaker recognition. And if you were to have access to a binaural audio or so, you can even say which location the speaker spoke from. And on top of that, there is this information about the acoustic sounds that happen in it, what environment it happened. There's so much of information there. So beautiful, right? Like, how do I uncover all of this? How do I, just with that signal, if I process it, how do I uncover all of these aspects? There's an emotion to it, and there is, and all that. So that was fascinating to me, because all of this was sort of embedded, encoded in that just 1D representation. And the moment we
Correct.
hear it, all of these are sort of separated out in our heads. So my thesis was largely inspired based off of that. It was, who spoke what and where. So basically it was on that. And when I joined as well, I was looking for a company which would allow me to continue my work on scene analysis and stuff like that. So that's where I landed up.
And some of the papers you've written that that you would think that's your best work. What are the genesis of those ideas? Acoustic source localization, for example. What is the general problem that you guys was trying to solve? What incremental addition that you made to the literature? If you can show some light on it.
Yeah. in my in all of my PhD work, I think one work that I'm like passionate about even today, I would say, is the work that I did in probably the last few months of my PhD. So what we were trying to do basically was, in my mind, this problem where multiple people are speaking at the same time. So first of all, audio is just a 1D signal. On top of that, you have multiple people speaking at the same time. And when you listen to that audio, you are now able to say, oh, Akash spoke this, Harsha spoke this, and Akash said this versus Harsha said this, and you can put that label saying this is Akash, Harsha, and all that stuff. So, and this is all about speech recognition, keyword spotting, speaker recognition, all that stuff. And the other hidden problem there in audio, which we don't really pay attention to in just the single channel audio, is the localization part. So basically, just based off of audio, listening to the audio, you can basically say which location the speaker spoke from. It's true of binaural audio. When we hear, we can turn our heads to the source of sound, right? But I, I sort of, if you look at multi-channel audio, humans of course cannot process them. But if you look at multi-channel audio, you can pinpoint the exact coordinates of the source where that sound basically came from. And this was sort of very interesting to me. So single source localization was a dead and beaten problem in some sense. There were really cool linear algebra tricks based works systems which were already in place. People toyed around that problem a lot, and there were pretty good solutions out there. But what was in some sense not so well researched was when multiple sources are present. How do you localize these sources to pinpoint accuracy when there are multiple sounds?
Do
And
you wanna
I
do you
sort
wanna touch upon that linear algebra trick that you guys used?
I mean,
Even
I
if
didn't
you
use
have to
that.
name it, not don't have to explain
Yeah,
it. But
I didn't use it, but essentially it was basically this beautiful paper written by Jacob Benesty and Yiteng Huang back in 99 2000, I think. The trick was, it's very simple, right? Like, you basically, if you want to localize a source based off of audio, you need to solve a set of nonlinear equations, in the variables being the coordinates of the source. So you solve for it. It's a nonlinear system of equations. We don't have great we do have great tools for nonlinear system equations, but they're not one-shot solutions in any way. They're iterative, right? You have to keep it. Now, these guys, with a nice, clever little trick, they converted the system of linear equations into nonlinear equations into a system of linear equations. And now you could just take matrix inverse, and this matrix was not bad at all, right? Like, it would scale linearly with the number of microphones. and voila, you get the result. And it was, if there are no, if there is not much of noise and reverberation and stuff like that, one shot you're done. Um, it's a super cool trick. And the trick had to do with sort of rearranging the variables and sort of rewriting some of these time difference equations such that uh, you you create a fourth variable, which is not really an independent variable, but you, if you treat it as an independent variable, you can just solve it, and so on. But anyway, so there were lots and lots of algorithms for single source localization. For multiple source localization, there were a lot of approaches, but it all felt like very algorithmic and stuff like that. So I wanted to really put my head down and sort of try to understand the problem as to where the complexity is. And basically, it turns out that if you go deeper, you'll see that there is something like a permutation problem that comes about. Um, One way to sort of localize these sources is based on time difference of arrival. So essentially, sound travels with the same speed in a given homogeneous medium, right? Based on the location of your microphones, it may take longer to arrive at a particular microphone and shorter at another microphone. But just of this difference in the time it takes to arrive at these microphones, you can basically you can you can reduce the probable locations of that source of sound to be lying on a particular hyperboloid. That's the geometry of the problem, right? It comes out to be a hyperboloid. Essentially, it's the locus of a point which moves. If you want to coin it as a plus two problem, it's the locus of a point which moves such that its distance difference between two fixed points is a constant, and that's exactly the time difference.
Oh, that's nice. That's a pretty
Okay,
neat idea. Yeah.
right. So it's just a hyperboloid, and now if you want to localize it further, you would have another pair of microphones, so it would be intersection of hyperboloids. And
Okay.
that's the interpretation for a single source. Now I wanted to see what I can do for multiple sources. And it turns out there is that if you were to look at intervals of these, one notion that I came up with, I mean, like working on this problem, is that just the sign of that difference, whether it takes more time versus less time to arrive at a microphone, that itself can narrow down a particular region um, in space. So I basically, that entire, in that problem, I was playing between the going back and forth between time delay space and the region space. So I would
Okay.
basically say a point in this space would correspond to a hyperboloid. A region would correspond to an inter-hyperboloidal regions, and then if you take multiple of those, it's an intersection of inter-hyperboloidal regions, so to speak. And based off of random arrangement of microphones, I was basically able to show that you can basically say, given an arbitrary region in space, you can say whether there is a source in it or not. So I felt like that was sort of very interesting, simply because the geometry of the problem was fascinating. So you could just go back and forth.
Okay. And is it this does it connect with the other paper that you have written, the raw waveform end-to-end
Yeah.
convolutional network, which is
So
essentially the spatial problem that you were talking about,
right.
having multiple sources.
So essentially, at that point of time, it was basically an intuition-driven, signal processing heavy paper, right? So it was sort of had a nice geometrical insight. And then what I wanted to do was to sort of catch up with the world, so to speak. I wanted to have a deep learning system which would basically do this automatically for us. Now, one problem with the deep learning system, building like an end-to-end deep learning system to do this, is how do we even emit the source locations of multiple sources, right? So basically, you had to encode it in a particular way, such that, again, this is about reducing the bottlenecks for learning. So essentially, if in an interesting way to sort of represent these coordinates of multiple sources, you can now have an end-to-end system. And on top of that, people were typically used to using spectrograms and stuff like that for localization. And this paper was based on raw waveforms. So you just input the multi-channel raw waveforms to this network, and it automatically give you the sort of the locations of sources which are active.
And
So it
just
was
going,
basically going from a signal processing approach and then embracing this notion that, okay, forget about what all you have learned about signal processing, see what you can do in machine learning, remove some bottlenecks.
and just to get, take something out of that non-linear to linear conversion, is it like generalizable? Like, is that trick can be used in lots of other scenarios? No, it's very specific to that particular
Yeah.
problem, right?
It's sort of specific to that particular problem. Again, it's sort of it's a clever play of the specific system of nonlinear equations that results in this time differences. So it's distance differences. Basically, you have something under the square root, right? So once you square it, what happens is some of these variables cancel out each other, and you sort of get a linear part, but some of them don't. It's very specific to that particular problem. I was also thinking about, oh, this is a cool trick. Has this been used before? I feel like it has. People have used it in sort of different in different ways, maybe. But in this particular space, at least, it was like a super elegant solution.
And the tagging paper that you had written, right? The event tagging, scene classification. What was the
That ties up,
central problem at that in that paper? I mean, that's
that
much more
ties up to
recent, 2022.
that ties up to the other the thing that we walked through a while ago, right? We were talking about what really gave generalization to these LLMs. I was talking about single task, multitask, and unification of tasks. So in this particular paper, we were focusing on multitask. So largely, acoustic event detection has been a single task paper, right? Single task approaches, and so on. And there's a related problem called acoustic scene analysis, wherein the idea is given an audio, you basically say what scene it corresponds to. Now, scene is an abstract concept, whereas an acoustic event is sort of a concept which you can tie down to time and frequency. You can say this is the sound of smoke alarm. You can say, okay, this is the pattern for smoke alarm. This is what it is in time and frequency and so on. But if you were to say this is a kitchen scene, there is nothing in the signal that says it's kitchen. But it's just that those events sort of there's maybe tap sounds, there may be microwave sounds, there'll be dishes clanking and so on, which makes you feel that it's probably a kitchen sound. So it's
Okay.
an abstract concept. So acoustic scene classification is about giving that tag of a scene, whereas event is about detecting that particular event. There was a notion that detecting scenes, the ability to detect scenes, might help the ability to detect events, or vice versa, and so on. So we were sort of, and there's a lot of literature back and forth, which is rather confusing to say. Some of them say it helps, and some of them says it's they go on to say that, okay, we use this for pre-training and then we fine tune it, and so on and so forth. But in this paper, we really wanted to see if there is that effect. If I use acoustic scene as an auxiliary task, does it help the main task of event detection, and so on and so forth? What we found out basically was a very sort of um, basically a lot boils down to data sets. So if you were to collect the data sets in the same environment and tag them for events and scenes, it could be helpful. But the acoustic scene data sets are completely different from event data sets. So what it turned out was, in all of these papers, it was most likely working as a regularizer rather than anything else. It was not that the knowledge of scenes was sort of helping. So we had some really interesting plots, a couple of plots in the paper, which basically shows this sort of hard to prove, kind of a empirically prove result, which says knowledge of a scene is not helping detect events.
Oh, okay.
So
That's like a non-intuitive insight from that paper.
yeah,
And another paper on polyphonic sound, which I think it was 21
yeah,
paper.
this was basically, I was trying to see what we can do with transformers, and at that point of time, the sort of the trend was conformers, convolutional transformer networks, and stuff like that. And one one intuitive thing about these transformer networks is the attention mechanism, right? So basically, it it figures out what to pay attention to in that particular signal when it's sort of decoding. So what I was interested in is when a network basically tags something as smoke alarm or speech, is it paying attention to the right parts of the signal when it's sort of decoding that? Is it looking at the right? So it should not. So imagine an audio signal where there is dog barking and then there is speech. The network clearly says it's speech, but if it is, if or it says it's and then when you look at what it's paying attention to, let's say there's a tool to do that, and if it's looking at dog barking, doesn't feel right. It's not explainable, and so on. So I was basically trying to see if I can come up with um, event specific attention, so to speak. Like for each event, I can again remove the bottleneck and create an attention layer which can focus only on that particular event, and so on. So for each of the events, there would be a dedicated attention or a transformer block which would pay attention to that. And what I basically showed in that paper is that uh, just giving a so the crux of the problem there was instead of having generic attention mechanisms for all the events and then decoding what event it is, it's better to have event specific attention within the same capacity, assuming the same number of learnable parameters you have. It's better to put those learnable parameters for each of these events rather than uh, as a generic thing.
Okay. So you shall we call it customizable attention?
It's not cost. I mean, so the network automatically learns. But
Okay.
the point is that event specific attention layer, it learns to pay attention to that specific event because it's the errors only from the speech node flow to that and so on.
Okay. Okay. Given all this, I mean, I'm assuming you're an optimistic person and you like research and knowledge and acquisition of knowledge to do social good at the same time work at the cutting edge. What keeps you going? And I'm assuming you have some interest in philosophy. You can probably touch upon as to how you find meaning in general. I'm assuming you're a big proponent of finding meaning in what you do. So, do you want to touch upon as to how you look at it from your vantage point?
Yeah, that's a great question. Something obviously I'm also in some sense struggling with is like to basically create a meaning for life, right? Like if one is successful to say this is the meaning of my life, I would say it's blissful because they know what that meaning is. They just have to go chase it. Just got to live it. But for a lot of us, I think that meaning is not ready made. We have to work at it. And then it's not for life. It could probably be for the next 1 year, next 2 years, next 3 years, and so on and so forth. And then just going on that journey makes you a different individual altogether. And now you're seeking for a different meaning and so on and so forth. So one breakthrough, I mean, one mental shift that I've had over the last few years is for a long time, I was searching for this overarching meaning for life or overall goal. So basically, I would like to say, if I meet you for the first time, I would say, this is the goal of my life. This is what I'm doing towards that. And then I realized that it was very difficult for me to come up with such a goal, and I could very easily criticize that goal in 5 minutes.
Hmm.
And then I realized that that's what, and I used to feel that is absolutely necessary for me to go on in life. And then I realized that probably not. That's not what I need. What I need. I don't know enough about this world and stuff like that to basically create that goal and freeze it.
Wow,
What
that's
I
a great discovery. Yeah,
what I
you're
can
right on.
do basically is I know where I'm right now. Probably from there I can extrapolate a bit further and have some goal. Based on that journey, that would make me let's say slightly better in some respect or whatever, or more empowered to create a more deeper goal and so on and so forth. So 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 with this mindset, I sort of resolved towards sort of having or attacking problems at the level of 1 year, 2 years, or 3 years, or some such thing. And again, I wanted to sort of go away from audio information extraction, and in came these LLMs, and which reignited that passion to basically say, oh wow, now there is a chance to basically understand audio in a completely different way. And I was not able to figure out a scalable way to understand audio, as I discussed before, like at different levels, right? Like the emotion, sentiment, speech, and stuff like that. And now it feels like there's possibly a way. If I keep sort of at it harder, there could possibly be a way to extract information from audio at multiple different levels. And I feel like, and why is that important? Why should we do that, right? I feel that is fundamental to building a technology which can understand humans. I feel anything that can just do speech recognition, anything that can do emotion recognition, anything that can do event detection separately is limited. Anything that can do together is great, but anything that can do that together and also keep track of history and sort of draw inferences from its own history and stuff like that, that's powerful.
Hmm.
When it can automatically decipher context. Context decides the content in a lot of times, right? So that I feel is as powerful. And one paper which sort of blew my mind in 2023 and which reignited this sort of passion is I would say generating agents, generative agents by
Yeah.
Stanford. I touched upon that.
Yeah.
That was
Yeah.
a beautiful paper. It was not so. After a long time, I read a paper which was not at all in my area completely, and I sort of thoroughly enjoyed that paper. It was simply because it showed a way as to how it unlocked in my mind what are the different ways we can use LLMs, not
Yeah.
just to answer questions, but basically to you can way to keep track of memory, self-reflect, and sort of draw relevant items from the memory and so on and so forth. So I feel like something like that needs to happen, but in a more multimodal. And then I've also started slowly realizing that it's just treating audio per se may be limiting in some sense, because the entire truth is not in audio alone.
Yeah.
Entire truth is not in video alone. Entire truth is not in text alone, and so on. So,
Yeah. And how does this tie up with your interest in Advaita philosophy? I mean, is it there is a direct correlation with you've figured out the calling, so to speak? People have a calling that okay, this is what gives me meaning. I'm going to do the research. I'm going to be the best in this, and that's my be all and end all. So, or
yeah,
is it like separate
as
from
I
your
said,
work?
I'm far from feeling that calling if that calling is already there. But at least I think with the rest, I mean, Advaita came in sort of a different way. I mean, basically, when I was working on all these problems, the fundamental question that I kept having was, who am I? Like, what's my purpose in life? What is it that I'm supposed to do? And so on and so forth. Right? It was a lot of noise in the head, as you can imagine. I did not have a good mental model around that, or how to think about that, or what's the framework in which I should sort of address. What is the space in which I should address these questions? I did not have that. I feel like I got some access to it by listening to one very powerful talk by Swami Sarvapriyananda, and the talk is exactly titled that, "Who am I?" And he basically talks about just one particular shloka, one particular four-liner from Mandukya Upanishad. It was brilliant. It was amazing. It felt like, oh wow, okay. Now there's that gave me so much more clarity about what the system is and stuff like that. And so so I feel like I don't think I've been successful to that extent to say, okay, Advaita has now given me a meaning, and that is what I find in my work. But Advaita is basically sort of given me uh, a way to look at myself in some sense, or and so on. And then I feel like work is something that is, I mean, there is a way to sort of work also gives you a window into yourself. Sometimes if you get to that deep level of work, and you'll see your characters come out of it in some sense. That's also another window into your own self. Without work, I would say, would be sort of really terrible. Um, so basically, I feel like overall, I think I'm fascinated to get to a deeper understanding of myself, in some sense, to see what my purpose should be and stuff like that. And these tools have at least made it sort of manageable. It gives me open in the wild, right? Like, if imagine if you were to be let alone in a sea without any direction, without any goal. You don't know what direction is. You don't have a compass. You don't know where you're supposed to go. Can be chaotic. Or if you just want to explore, it's fine. But if you want to get somewhere, and if you don't know where to get, it's difficult. But these at least are like sort of a rough compass, which would say, okay, this might be a promising direction to go towards. And keeps that explorative spark alive.
Yeah, I mean, you didn't ask that question to me, but if I have to think about the people have asked that to somebody like me, or for that matter, anybody, and they say, "How do you determine what the meaning of life is?" And recently, I've come up with a nice answer, which I gleaned from Sam Harris's mindfulness podcast. I think Waking Up is the name of the podcast, and I think he does a bunch of things in that space. And I think just if you don't know who he is, I think he
I've
was an
heard about it.
undergraduate. Oh, he's an undergraduate from Stanford, and then he went to India for like 10 years and meditated and figured out a lot of stuff. And what he says is essentially the meaning of life is to not ask the question what the meaning of life ought to be, by the corollary of which follows that you have to live your life every day to the fullest to a point where you don't get into the contemplative state of figuring out, oh, am
Right.
I doing the right thing? Because the babies, a
Absolutely.
2-year-old baby is in that state wherein it's just exploring and going about living its life. It's never in a
Yeah.
contemplative state.
Yeah.
So that's a very interesting
That's
point of view.
absolutely right. I mean, so that's what I feel knowledge in some senses, or gnana marga, so to speak, in Advaita or whatever. Right? Knowledge is not always about answering the questions, but it's also about not asking, yeah, about asking the right questions, and sort of ignoring the not so relevant questions. Not so relevant questions, as I said, would occupy a lot of your mind. Who am I? Probably needless, and it's not even necessary, right? How do you silence your mind towards those irrelevant questions? And even that sometimes requires knowledge or requires awareness in some sense, right?
Awareness more than others. Yeah, yeah. And do you follow any meditative practices that gets you in a place on a daily basis? And has it
And
helped you in research?
yeah, that's a great question. So one book that really helped me with that was The Monk Who Sold His Ferrari.
Okay.
So in that
Robin
book, I
Sharma.
think Robin Sharma, I think Robin Sharma points out to Heart of the Rose meditation, wherein the idea is very simple, right? Like you basically have an object that you meditate upon. You just stare at it for 15 minutes and basically allow the mind to do whatever it does. But the point is to look at the heart of the rose and not gaze your attention. So I did that religiously for quite some time. It did help. But then I was thinking about meditation in general. Like, okay, what is meditation? What is, again, this question about what is the problem to which that is a solution kept bothering me. And recently I bumped into a beautiful book called A Million Thoughts by Om Swami.
Okay.
He's a fantastic author. There was another book that I read about his, which was Wellness Sense. But this book is a pedagogic exposition to meditation. That's how I would put it. It breaks down meditation very clearly to say what it is versus what it is not, and basically empowers the reader to. Again, I love Om Swami's book because he empowers the reader to choose their own meditation and not prescribe that this is the meditation for you, right? Or
Yeah.
this is
Yeah.
what you should be doing and stuff like that. And he opens up this entire field of meditation wherein I now can become an artist to construct my own meditative scheme as to see, figure out what works for me.
Yeah.
That I feel is like really powerful. Same thing with wellness sense, right? Like I was ignorant about Ayurveda and sort of the what food to take in and stuff like that. I'm not. I feel like I'm still pathetic in terms of application and stuff like that. But at least it opened my mind to. It made me aware that I'm really bad about something or whatever. So it and it was not about. And it was not about, he was not prescribing to say this is good versus this is bad. It's just that if you do this, this is what you're going to get. If you do this, this is what you're going to get, because your system is this. It gives you a very good intuitive black box description of your digestive system.
Yeah. Yeah, that's great. So, given that, I mean, we just want to wind out with one or two final questions. Where do you see the future of AI in the immediate past? That would be a nice end note. And also, what kind of advice would you give to an aspirational machine learning person or somebody who's interested in speech or somebody who's interested in LLMs? I mean, because of the explosion of all these models on Hugging Face and a bunch of other platforms, it's like you're inundated with lots of information. As a
Yeah,
result, for somebody new who doesn't have a framework to look at, it becomes he becomes completely lost. He or she becomes completely lost. So, how would
yeah,
you advise younger people, and what are
yeah.
the immediate things that you're looking forward to?
I would first of all think that I'm also still young and I also need advice. I would refrain from advising somebody, but I can definitely share what has worked for me, and if it helps somebody else, that's great. What I get bogged down with this amount of research, and it's very difficult to catch up with literature and stay there. Like you can't be aware of all of the papers that get published all the time, all the techniques that are out there and stuff. But I think last year I made it a mental note to say I'm going to at least read a few papers and sort of share them or write them or whatever, and so on, right? So what that what that exercise helped me do was, you will see very quickly that you don't necessarily care about or have to keep track of every paper. A lot of papers probably are not interesting to you. So at least you will come up with your own ways to filter out the irrelevant papers. Um, and and it, and the point is, and these papers, I feel like they can also spark thinking in you. The right papers can basically spark thinking in you, and for that right papers, nobody would can probably. I mean, sometimes people can recommend. It's definitely there, but nobody will come to you and say, "Hey, this is the most powerful paper. Please go read it." So you've got to keep trying and stuff. This period of time is beautiful, as it has lots and lots of information, and that's also a curse in some sense. So finding the needle in the haystack is the problem right now. It's not about finding any book on the topic, right? Like you will get thousands of. What I would definitely recommend is to get started somewhere. Don't put not get too bogged down about where we start or whatever, but just starting somewhere, looking at a particular code base, trying it out, see how it works and stuff like that. Again, the point is about failing fast. You have to take up something, try, fail, get the feedback of what's not working, and then sort of improve upon it very quickly. Like with 2 or 3 iterations of it, sometimes, or 4 or 5 iterations, you're at a better place. You have a better hold of, if it is literature review, you are at a better hold of where the literature is. You know what sorts of things have been done versus what sorts of haven't been done. And the idea is also not to read the paper fully, in my mind. To me, what was more advantageous was to basically go through the abstract and decide whether it's worth my time or not, and then sort of move on. That with that, you will be able to sort of cover more papers and get a sense of where the idea is and where you want to focus on. With respect to ideas and code bases, it definitely helps to sort of go down the code base and see what people have done. It will give you inner strength to see how something is implemented. Try it out, see, make that model run once, get its output, and assess some output, something you'll be curious about. Chase the curiosity, right? Like to a certain extent, not following the literature or whatever. Trying it out will basically already give you a good sense of where that model is. The next time you read a paper related to the topic, you'll be much better in a different place. So to me, what has really helped is to compare what I was versus what I am very strongly, and sort of go from there and have a sense of which direction you want to go towards. So for any machine learning enthusiasts who want to get into the field, I think they should definitely not ask the question about where the jobs are, but also not just ask about question about that, but also think about what is it that they really want to do, like what kind of signals appeals to them. I mean, not everybody would like audio, not everybody would like text, not everybody would like to work with video, although there may be great things happening there. Doesn't mean that you should work there or whatever. So that is also sort of important. Once you have that, reading some papers, trying out some tools, trying out some repositories, understanding the core of that field somehow, which gives a lot of confidence, and that can be carried out in, that will show up in the interview process, and that will also show it in your work, right? Like if you're really comfortable with the fundamentals and stuff like that, you'll be much more efficient in the work.
And the immediate AI that you personally are very interested in, can't wait to get your hands on some model or some interesting theory that's out there. What are you looking forward to? You're looking
Oh,
forward to all of them?
no. Of course not. If I'm looking forward to all of them, I'm looking forward to nothing. It's
Oh,
almost
okay.
like focusing on everything. But I think, as I said, multimodal LLMs are something that I'm really passionate about. Some of the papers that have come out, tons of papers on that already, by the way, over the last few months. But not all of them treat audio modality very seriously. To be honest, it's audio modality is almost like a this
Afterthought.
little guy hanging out there with the big ones in some sense. So not a lot of serious work has been done on the audio front, but yeah, and also not a lot has been done on the planning and reasoning front of it in some sense. um, so there is this audio, video, text to a certain extent help you perceive the world, and then what do you do with it? what how does the what do you do How do you use that in your body of knowledge, plan it, and then take some action out of it, is also something that I'm really passionate about. So connecting all of these is what I'm looking forward to. I still don't know well enough to articulate the problem well. But I think these are some of the topics that I'm sort of more curious about.
Yeah. Thanks, Harshvardhan, for doing this. I mean, we are doing this as a series, and I think this was a huge boost. And also, you as a person is very interesting amongst the researchers, right? Every time I talk to somebody who's a researcher, I think they have a particular language they're comfortable with, and it's almost impossible to get them out. And you're very comfortable. You're like a generalist, so to speak, in that sense, at least in terms of language ability and able to communicate. Thanks for doing this. It was very
Okay.
helpful. And
Thank you so much for the opportunity. I mean, just talking to you and the questions that you asked itself made me think about it in some different ways and sort of, help me understand myself. So you have helped me in that way. So thank you so much, I would say, for this opportunity.